Alrighty, welcome everyone. Today we're going to be having a look at the gradient, which is half of our linear equation in a sense, because our general equation is y equals mx plus c. And in this case, we really just want to care about one particular part, which is m. Everything else, we're not so stressed about. Why? Because it doesn't have anything to do with the gradient. We're just interested in the gradient, what it does, what it looks like, how do we deal with it. Okay. So let's start off, first of all, by having a look at a line. Now this is a line I've drawn earlier. I'm just using a program called Geogebra. It's a really powerful one. It allows you to do all sorts of things. Now, if I have a look at this, when I'm looking for the gradient, what do I do? Well, I look for 2 points that are located on the line. You see how they're on the line? But not only that, I make sure that those points are nice and on across. I don't want it to be sitting like here, because I'm not going to be able to read it properly. I want them to be lining up nicely on the grid as well. If you want to have a play around with GeoGebra and you want the grid, just make sure you right click and put the grid on. Makes this a lot easier to play around with. Okay, so once I've got my 2 points on the thing, then what do I need to do? Well, I need to count. I've firstly got to count across 1, and then I go up 4. Actually 5. So across 1, up 5. Does everyone see that? I've gone 1 across, 5 up. Well, what's my gradient going to be? Well, my gradient is defined in this way. It's going to be 5 up over 1 across. So it's the change in y, the rise, over the run, how far across you've gone. So in this particular case, let me just turn off some text. And I'll turn off this one as well. I'll turn them all off. So you can see that we moved 1 across, 5 up. 5 divided by 1, because we've risen 5. And we've run 1. We've gone up 5, 1 across. And 5 divided by 1 in this case is just 5. So I'm going to write that as the gradient of this line is 5. Let me change the gradient just for a second. Let's make it something different. Okay, so now my gradient has changed, but I still need to find a point that lies on the line. So when I'm looking for the second point, I want to make sure it's on the thing. It's quite nice. It's still working down here, but now I'm going to be looking all the way up here. Well, this time I want you to have a go. How far up did I go? How far across did I go? Pause the video, see if you can work it out. Well, in this case, we've gone up no longer 5, we've actually gone up 6. If you count it up, it's 6 spaces, but we've gone across 2 spaces, not 1. And if you go 6 divided by 2, what do we get? 3. So the gradient of this line is 3. Now, before I just move on, I'm actually going to change my gradient again. And this time, I'm going to make it something a little bit different. So, alrighty. Well, I could choose any point. So I'm actually going to choose this point all the way down there. And for my second point, I'm going to choose this one all the way over there. The rule is that as long as they hit nicely on the grid, you can choose any points you like. Alrighty, well in this case, I've gone 3 up. And how far have I gone across? Well, I've actually gone 1, 2, 3, 4, 5, 6. Got to move my text box out of the way. 7, 8, 9 across. So it's 3 over 9. Okay, well if we type that into a calculator, you'll get a third, or 0.3 recurring. I actually prefer a third in this case. Why? Because a third gives us a little bit more information. Okay? Because the third tells us that it's actually 1 for every 3 across you go 1 up. Because we're rise over 1. Or you rise 1 for 3 across. Alrighty, let's continue playing around with it. I'm going to change the gradient once more, and I want to see if you can figure out what the gradient is of this one. So pause the video now, see if you can work out what the gradient's going to be. Alright, so first goal, got to be find 2 points on the line, and I see 2 points just like that. Alrighty, so how far up have I gone? 4. How far across have I gone? 5. So this one is going to be 4 up, 4/5, and we could write this as 0.8, but 4/5 is actually probably a little bit easier. So 4/5 is going to be my final answer for this one. Alrighty, well these have all been nice positive gradients, but the thing is when we're doing this, sometimes we're not going to be running into positive gradients. Sometimes we're going to have negative gradients too. So let me show you one. Alrighty, so this is quite a steep gradient, you'd see, so I might zoom out just a little bit. Alrighty, so I'm already stuck on one point, one here, and I'm going to find another point down here. Okay? So this time I've gone 1 across, and I've gone 1, 2, 3, 4, 5 down. So when I'm writing this in, I can't say 5 down, so instead I write it like this, and I ran 1 across. And -5 divided by 1 is -5. So the gradient of this line is -5. Alrighty. Now let's keep playing around a little bit. We'll change the gradient again. And I'm going to change other part of it. Alrighty, so this time I want you to have a go. Tell me the gradient of this line. Pause the video if you need to. Alrighty, once again, we're looking for 2 places in which it hits the line. So I can see quite a nice hit there, and I see another hit all the way down here. So I might use that one. You chose different points. As long as they were on the line, for example, this point right here, probably will work as well. You're just going to put a slightly different working out, but your answer will be the same. So let's go through and do it. Alrighty, well how many steps am I taking down? I'm taking quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps down. So -10, and I took only 2 steps across. So that's 2 steps. So -10 over 2, well, that equals -5. And if you did it the other way, you still would have got -5. So there's the gradient of that one. Alrighty, I'm going to show one more example. So let's move my little marker thing all around and change this. There we go. Alrighty, so this one's a little bit different. So let's find some points. I see a point over here, and I see one down here. Alrighty, so let's count how many steps across I take. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've run 9 steps. How many steps have I gone down? I've gone 1, 2, 3, 4, 5, 6. -6 over 9, which simplifies to -2 over 3. Or I could write it as -0.66666, but it's always better off to show it as a fraction. You're always going to get more information that way. So there it is, just like that. Alrighty, I'm going to give you one more to have a go through. So this time I'm going to give you and you. Alrighty, so work out the gradient of this line. Alrighty, so first of all, let's work out where 2 points are. So I see a nice point here, and I see another nice point all the way up here. Perfect, okay. So I've got a beautiful right angle triangle. So I've gone down 1, 2, 3, 4, 5, 6, 7, 8. Down 8. And I've gone across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. negative 8 over 10, which simplifies to negative 4 over 5, or negative 0.8. Either way, if you got that, easy enough. Alrighty, so that is how you find the gradients on a graph. But graphing isn't the only aim of today. We also wanted to do it from 2 points. So for example, imagine I had 2, 6, and my second point was 4, 12. And I wanted to know what the gradient was between these 2 points. Well, if I'm smart enough to have graph paper with me, well, I just need to plot the points. Alrighty, so I've got to draw up my axes, and then I've got to go, well, that's 2, 4, and then I can go all the way up to 12, 1, 2. See, this is a bit of a pain, isn't it? Especially when I've got a large number like 12. This is going to take me a while to just even plot it. So there's got to be an easy way, and there is. We define it as rise over run, as we were doing before in the graphing software, but we also have another definition which is more useful. Sorry, not m. Well, m is the gradient, so I'm actually going to leave it as m. Remember, m, gradient, the same. But the other way we define it is like so. Like that. And the reason we do that is basically we're doing the same thing. The rise is how different are the y coordinates, and over the run, which is the difference in the x coordinates. Okay, so let's use this equation. Get rid of old rise over run. It's only useful when we're looking at graphs. This is useful when we're looking at points. So let's have a go through. So there is, I always like to color code them red and blue. So red is going to be my x2, y2, and blue is going to be my x1, y1. So let's substitute into this equation and get going. So in this case, it's going to be 12 minus 6, 4 minus 2. And if we work that out, 12 minus 6 is 6, 4 minus 2 is 2, and the gradient is 3. Alrighty, so your 2 points are going to be 2, 6, and instead we're going to have 5, 9. Have a go at that one. So pause the video, see if you can have a go. So once again, x1, y1, x2, y2, and let's go through the formula. M equals y2 minus y1 over x2 minus x1. Red points first, 9 minus 6 over 5 minus 2. In this case, 9 minus 6 is 3, 5 minus 2 is also 3, and 3 divided by 3 is 1. So the gradient between those 2 points is 1. Remember, any 2 points on the line will do, so as long as you find 2 points, it's nice and easy to work it out. Alrighty, so that's where we're working at it like that. But remember, sometimes we don't get nice answers, so let's look at some of those. I'm going to have a look at 2, 5, and 6, negative 3. Okay, so it's a little bit more difficult because I've got these annoying numbers now. But if we label it up, it's no trouble. x1, y1, x2, y2. Let's use the formula. Actually, I'm going to put that in red. And let's go through the formula. Alrighty, so formula is m equals y2 minus y1 over x2 minus x1. Let's start substituting in. So we get equals minus 3 minus 5 over 6 minus 2. Okay? And if we work that out, minus 3 minus 5 is minus 8 over 6 minus 2 is 4, and we get negative 2 as our final answer. Alrighty? Your one is going to look quite similar. I'm just going to change this to a minus 2, 5, 6, negative 3. Have a go at that one. Once again, always start by labeling. Makes your life a lot easier. x1, y1, x2, y2, m is equal to y2 minus y1 over x2 minus x1. y2 in this case is minus 3. And this is the trick. Minus negative 2. We have two minuses, one from the formula and one from up here. Got to make sure you put two minuses there. So you're going to get negative 8 over positive 8. And in this case, negative 1 is the gradient. A little bit of a trick there just here. So whenever you have a negative, it's always a minus sign in between the two numbers, but sometimes there's going to be two minus signs, one from the equation, one from the number itself. Alrighty, so that takes us through how to do gradients both in a graph and also if you just know 2 points. Alrighty, see you next time. Bye-bye.